Physicists have measured the skin of an atom for the first time and, perhaps unsurprisingly, it is extremely thin. The measurement may help us understand the properties of neutron stars. Lead-208, an isotope that contains 82 protons and 126 neutrons, has a type of nucleus that physicists refer to as doubly magic because both the protons and the neutrons are arranged neatly into shells inside the nucleus. These shells keep the atom relatively stable and make it simpler to experiment on, so when the PREX collaboration at the Thomas Jefferson National Accelerator Facility in Virginia set out to measure neutron skin, they opted to experiment on lead-208. Because lead-208 has so many more neutrons than protons, the neutrons and protons are only mixed together in the center of the nucleus, with some neutrons making up a layer around the edge. We already know the density of protons inside the nucleus from previous experiments. As the neutron skin is created by the interior of the nucleus being so dense it squeezes some neutrons to the outside, measuring the thickness of this neutron layer reveals the density of the nucleus as a whole. It tells us something fundamental about how nuclei are put together, and that piece of information really tells us how difficult it is to push neutrons into matter when there are already a lot of neutrons there, how hard it is to make matter more dense, says Ken Pashka at the University of Virginia, a spokesperson for the PREX group. The researchers measured the thickness of the neutron skin by sandwiching a sample of lead-208 between two diamonds and bombarding it with a powerful beam of electrons. The way the electrons bounced off the lead revealed where in the nucleus the neutrons were located. The researchers found that the neutron skin is about 0.28 femtometers, 0.28 trillionths of a millimeter, across, very slightly thicker than physicists had predicted. Understanding this fundamental fact about nuclei could help us understand the pressure inside neutron stars, which are mostly made of neutrons, which may help set a limit on their size. The physics that is responsible for the skin of lead-208 is also responsible for the size of a neutron star, says Jorge Piquerowitz at Florida State University. Gravity wants to crunch the neutron star and make it a black hole, and something is stopping it from collapsing. That something is the same thing that makes the neutron skin.